Hello and welcome back. My name is Corey and you're my rubber ducks, and this is the series where we are creating a programming language from scratch. And today is the day I've been waiting for. We are going to start using ICU. And it's also been the day I've been dreading. Why? Because quite frankly, this is hard. Well, it's how about this? There's a big knowledge gap you have to overcome. ICU in and of itself is fine. I have been trying to record this episode for 5 days now. Of course, if you've been following along, you would know that I've had an episode coming out every day. But what you didn't know is that I had worked ahead, and I had over a week's worth of episodes pre-recorded in case something like this happened. And the something like this was that, quite frankly, I couldn't get it to work. I could not get ICU to do what I needed it to do, and that was bad. Uh, yeah, that was very bad. So, what happened with it? Well, as it turns out, it's one of those things that there was one time I thought I was wrong, but I was mistaken. That's what this was. It worked the first day. I had a misunderstanding about how something was supposed to work, and I thought it was broken. I even posted on Stack Overflow, and that question is still up, and no one has answered it. In fact, I'll probably go back and edit my own question, because one of the hardest things about working with ICU is the fact that unless you already know how it works, it's very difficult to get documentation on it. And they actually have Doxygen generated documentation, and but that's not enough. You need code samples to say, how does the library work? And anyway, okay. Having said that, we're going to get started. Now, if let's just go to the code. I always say this is 100% live coding. That means you see me and my mistakes and everything. I have not prepared the code I'm going to write. I have written similar code other times. I've said this on other recordings that I've actually written a programming language twice in preparation to record this series because I was trying to decide how I wanted to solve some problems. And I'm solving them differently in this series than I did in the other times I wrote it. So I'm not copying and pasting. And so you're going to see the errors and everything like that. But when it came to ICU, I had so much trouble. Originally, I was working in Ubuntu 20.04, and its version of ICU is older. So in order to get the most recent, I had to download it and compile it from source and then figure out how to link against that and everything like that. And it's not as straightforward as you would think. But now that we're on 22.04, Ubuntu 22.04, we can use the version that is pre-installed. So how do I get this? I mean, it was pre-installed, but if I say apt list installed and do a grep for ICU, will that work? Yeah. These are the three libraries that you need: ICU DevTools, libicu dev, and libicu 70. And the 70 is actually the version number, even though if I pull up their documentation, they're actually on 72. This is what's installed on Ubuntu 22.04. So that's what I'm using. And ICU has been around for a long time. That's okay. In other words, what I'm saying is it's a mature project, but because of that, it was sometimes written in an older way. Yeah, that might be a good way of saying it. And where is this? Just looking for something that I can show you. And guess what? I'm not seeing it. But, okay, so when we compile, of course, we need to add the libraries for ICU. And the easiest way is there's a pkg-config. And, you know what? I think if we do man this, we can, is there a list all? Yeah. So pkg-config list all. And these are all of the packages that if we were compiling, well, I'm not going to say all of them act this way, but if we don't know what flags we need to include, that's one of the uses for pkg-config. And there's ICU-internationalization. And I think there's some others. There is ICU-UC for the common data libraries, as you can see there. ICU, of course, I didn't say that starting out, means International Components for Unicode. So, as part of that, we're going to do something like pkg-config, and if I were to say ICU-UC, well, I didn't tell it what I need out of this. The libraries. And it would give me the command line flags. And in fact, I think we can also add, is it C flags? And, well, in this case, it doesn't add it. But I know that from when I installed this from source, that the header files and then the includes were given in a different area. So I installed in a different area. And if you include the --C flags, it will include the -L and -I flags for your compiler that will say where the header files are and where the libraries are. So, yes, that is handy. And in fact, you know what? If we were to say gtest, in fact, yeah, these are -L gtest, and that means define gtest has pthread 1. So, let's get started, shall we? Of course, I always say git log. The very last thing we did was episode 44. You can see that at the top. And if I say git status, there is no other code that has changed. I always say nothing up my sleeves, right? All right, we're gonna jump in. Now, what does this need to look like? Well, I'm trying to think, what is the nature of our language? The nature of our language is to generate templated things. Why do we need lib, or why do we need ICU? Well, ICU is the standard. Unicode is complicated. I'll put it like that. And there are a lot of videos out there, and I don't know, one of these days I may do one as well, for the difference between Unicode versus UTF. In short, Unicode says there's a list of symbols, and it starts off with the ASCII symbols. You're probably familiar with that, and where number 65 is an A, I think. Number 32 is a space. And it starts off with that, and it just extends it for thousands. And so Unicode defines the list. UTF-8 is to say, I've only got 8 bytes. How do I encode these numbers into those 8 bytes? And there's more than one way of doing it. There's UTF-8, UTF-16, UTF-32, and there's Windows, I think, as an operating system, use UTF-16 internally for everything, and UTF-32 is also possible, but it uses up a lot of extra space, basically 4 bytes per character, whether you need it or not, and so that's pretty big. And we are going to stick with UTF-8, but, and this is one of the things I had to learn is that internally, ICU uses UTF-16. And so we will have to convert things into UTF-16, or rather tell ICU that we need to convert it into from UTF-8 so that ICU can work with it. And we don't want to have to do that a lot, but I don't think that we're going to need it all the time, because most of the parts of the template that you're going to see it's going to be processing in other ways. The only reason that we need ICU is to not break apart code points. Or excuse me, no, that was the right word, code points. And what do I mean by that? Well, if you were to say, what constitutes a single character? And you might say, well, the letter I is a single character. The letter J is a single character. Yeah, that I would agree with that. But what about an I with 2 dots over it? Or an O with 2 dots over it? Or the C with a cedilla? Cedilla? I don't know how you pronounce it. Cedilla, maybe. I don't know. Or all sorts of different characters. Well, they take up more than one code point, so to speak. And in fact, I think that there is not a limit. You can stack code points. And so if we needed to, for example, reverse a string or just get the first 3 characters of a string, you don't want it to cut off those code points. So in terms of ICU, we talk about graphemes. And graphemes are that thing that we intuitively talk about as a character. It is a collection of code points that when you put them together make one thing. That, at least that's how you and I would interpret it. And under the surface, it may take a lot of code points. There are some flags. Is it the flag of Scotland, I think, that takes a lot of code points. We may look that up as one of our tests. And if we need to reverse a string, or we want just the first character, we don't want it to cut off all of the code points, because all of those code points put together. Okay, the rules are complicated, and that's what ICU is for. It's been around a long time, and they've done a lot of really good work for the internationalization that we need. Okay. Having said that, then what's the next thing that we need to worry about? The next thing that we need to worry about is how do we wrap our work around it? Okay, so we are going to have to define a class that will hold our string. So far, we've just been using a string class, but we need to have a class that will hold our strings that we can I'll say it that way. They can hold our strings that we can use as a drop-in replacement for the standard template library strings. Not standard template library, that STL. The STD, the standard namespace strings that we've been using. And I've talked long enough. Let's just get into the coding and see which directions we need to work in. So the first thing is we need a file to test with, and we need to start building our class that will hold our strings. And so for that, let's edit our make file. And I'm just going to go to the bottom, and we've got our test, our singleton object pool, our garbage collected, and you know what? I think I'm going to put our main test as last. Why? Because singleton object pool should be before garbage collected, and garbage collected has to work before our normal tests. But now also we're going to run our string tests. And what do we call this? We're just going to call it Unicode string. Test Unicode string. Now, yes. Say, Corey, are you arguing with yourself again? I most definitely am. And there we go. And we will call this a Unicode string. And now we need to do our object file for it. Is there anything else? Don't think so. All right, so this is going to be called Unicode string, and it's going to rely on Unicode string.cpp and string.hpp. And is there anything else? No, nothing else. So Unicode string.o, and then I'm going to, didn't need to do anything there. That's good. Now for our test, test Unicode string, and it's going to need sorry, I'm just trying to think of how I want to structure this. I think that's right. So the test is going to rely on Unicode string. There we go. And we're not going to include Tang library. We don't need that. But we may need on the LD flags. So we've got the C++ flags and the LD flags. Let's just put it here. And we're going to do this pkg-config. And what does it need to include? I wrote this down because, quite frankly, if you get them in the wrong order, it doesn't work. I'm going to do libs. I will include C flags, even though we don't technically need them unless you're compiling from source. ICU-IO, ICU-I internationalization, and ICU-UC. And yeah, if you sometimes get them in the wrong order, it won't work. So just making sure in our test we are using the LD flags, all right, and that will give us test Unicode string. And now if we test, run string tests. All right. This probably won't work. Well, we haven't created the test file or the .cpp or .hpp. That's all right. We'll get to it. But I do want to say make test-watch so that it will start doing this. Okay, it doesn't know what to do for source-unicode string.cpp. And did I include CPP and .hpp, but because it couldn't find this one, it just stopped there. That's fine. All right. So now we need to touch a file called include Unicode string.hpp, touch source Unicode string.cpp, and touch test Unicode string.cpp. Oh, I misspelled it. All right. So let's edit now our include for Unicode string, our source for Unicode string, and our test Unicode string. These are the three files we need. Let's see. Normally what we do. File, and what is this? This is ICU library. There we go. We're going to interface with that. And pound if is it if and def, or is it all lowercase? I don't know. There we go. And this is going to be, how do I normally do this? Is it Tang Unicode string? I don't think I normally do that. All right, so now we can do some work. I know I'm going to need to pound include, I wrote these down as well because, yeah, it's hard to remember. Unicode uconfig.h and There we go. Use string and break iter. We'll talk about what we're doing with these in a little bit. A few other things that I know we're going to need, and ICU says include the standard template libraries first that you need. So, okay. We're going to use string and pound include that may be all we need for this. No using namespace in your .hpp files. But we are going to have a class called Unicode string. See, I remember the semicolon. I always forget that. And what all do we need? We need a string, and we're just going to call that source. And we will create a constructor and say that should be fine. And now, as always, we need to do our documentation, and that is at param is source, and we're going to say the UTF there's so many different ways you can do it. Encoded string. All right, and now this is going to be that should be fine. Now it's going to tell me, hey, I'm missing some stuff. At least it should. And we're going to edit. Oh, nope, just go to the next one. So Pound include, and now what all do we need to include? We need to include Unicode string.hpp, and we need to pound include. I know we're going to need a vector. And I also think we're going to need pound include cassert. And now, okay, evidently I just accidentally deleted that. Cassert, and now I and you are right next to each other on the keyboard, and when you hit undo and then accidentally hit another thing, you can't undo it. Yeah. So using namespace standard, using namespace Tang. All right, so now we've got this, we need our constructor, and that is source, and we're just going to say source. Don't think we need anything else yet. Unicode. Oh, did I copy all of those wrong? Okay, so test Unicode string does not exist yet. So we're going to do that one next. Now that I had that one video where I spent 3 hours recording and there was no sound, I'm paranoid, so I keep on going back to check my OBS screen to make sure that everything is still running. All right, so this is our test, and what is this? Gtest, that's what I needed. And we're also going to need pound include Unicode string .hpp, which will include all of the sorry, I'm arguing with myself again, as usual. So, see these? I don't think these need to be here. I think they need to be in that one. And now we're going to, at the bottom, yank that, and now we'll have our main, and test. What's the first test that we're going to make? You know, we'll just say AA. Who cares? We'll come up with a name for it in a little bit, and then expect EQ 1, 1. There we go. And so now I probably forgot to do something in the make file, but that's fine. We'll fix that now. So in the make file, after test Unicode string, no such file or directory. Let's just scroll up a little bit and see what we have here. Did I not include it as a dependency for a test? Maybe. Test, what did I call it? Unicode string. There we go. All right, so now we've got our Unicode string up at the top. And so if it fails, then it'll just stop there. That's always good. Well, we have to edit these again. And the question is what should this do? In short, I want to be able to, my goal for today is to be able to break apart a string into the graphemes. Okay? Graphemes. And again, the graphemes are what we would think of as a unit. So, our first test, what we're going to do is I do like what I'd started the other time, is creating this here, and we're going to say a string S, and right now we're just kind of defining what should this look like. And so how about rather to say a using namespace standard, using namespace Tang, and this should be a Unicode string S, and we're just taking, yeah, we're feeding it, well, this. We'll see if it'll do it. Okay. Doesn't like the way I'm calling this. Unicode string with a what do you not like about this? let's check out the compile string. Probably just left something out. These function. Oh yes, because this is a one-off. We're not using the standard set of things. So let's I have to edit the make file again. And in order to do this, look for the word Unicode, Unicode string.o, not there. Oh, but the test. This is what we need. So before we do the LD flags, I want to include obj dir object dir slash Unicode string.o. Okay. It has run. We've got the string test. Good. That was the problem. All right. I think I can go back to this now, and we should still be fine. We are. Now, what do I want? I want to do an expect EQ, and I want it to be a s dot subster. Is that in C++ what a strings thing is? Oh, I pulled up the ICU homepage, but C++ string, just give me a C++ reference. That works. Yeah, subster. And it needs a position and length. Both size t. So I want a 0, 1 to be equal to something. We'll worry about what in a little bit. But first, that means we need to create this function. And that's what we're going to do now. So this is going to say return a Unicode grapheme aware substring. And it's going to need the parameter of location and what do we call the other? Oh, position and length. That's fine. Position, length. Position. The zero-based position of the first grapheme. Param and position and length. The number of maximum number of graphemes to return. And at return is going to be the requested substring. How about that? So this is going to return, though, a string subster size t position, size t, length. That's the goal. Now, let's create this. For the moment, we return nothing. The test will pass. Well, it should. Oh, unused. Nah. I was going to say I could just write something. Who cares? I mean, I'm not going to. Now, let's just... In order to... okay, so I need to cast the source into a Unicode substring. So I'm going to do that as auto ICU Unicode string. Now that's why we have namespaces, right? I'm calling mine Unicode string and ICU calls theirs Unicode string. But an ICU Unicode string, and they have a static method. Do I have a link to this? There we go. You see, they're using Doxygen for theirs. They have a method, and this is, we'll use the search up at the top. Is it create? Or is it from UTF-8? Yeah, from UTF-8. There we go. And it is, you can see it's a static, up here, static Unicode string from UTF-8. And passing it a string will be just fine. That is UTF-8 encoded. And what we're going to do is we're going to always store ours as a UTF-8, but it is going to... create the string. It will convert it into the UTF-16 representation. Yeah. A Unicode string with equivalent UTF-16 contents. So, all right. Let's get that out of the way. And make it so that I can still monitor my recording. So, all right. What did I say? From UTF-8. Okay, maybe I shouldn't have covered that up. Yeah. The capitalization from UTF-8. And what are we going to pass it? Oh, of course. This arrow source. And now, I didn't give the variable a name, but we will say this. How about uString? Okay. Now, I'm going to do this very naively. And what is it called? It is... I have to go up to the very top. Subster. But I don't think it's, you know what? Let's fine. Let's try it. I don't think it's going to work. But it does use position and length. So that's good. If I were to try to just return uString.subster of position length. Let's just see if that works. The answer is I don't think it will, but there we go. Yeah, Unicode string has no member named subster, so even though that belongs to a string piece. And What is a string piece? There we go. Oh, well, this is the... I was hoping thought it would take us to the documentation. It did not. A string-like object that points to a sized piece of memory. And for this, non-explicit signal, blah, 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 blah. Basically, yeah, it's not what we need at the moment, unless there's something I'm missing, and hey, that could be the case. But I want to go back up to the top and do a different search again, subster. Is it because it's not starting with it? I know what I'm looking for. That's what I was looking for. So the Unicode string has this temp substring. And what is the point? What is this thing with a temp substring? Well, it does return a Unicode string, but it's like a memory efficient way of doing it. It doesn't actually copy the content, and you can see it here. The object return will be a read-only alias. As a result, this substring operation is much faster, but requires that the original string not be modified or deleted during the lifetime of the returned string object. So it's just a way of being more efficient, but it's we just have to work around it. So we could do this. We could say temp sub let's see, substring, and is that, yeah, that's a substring, and that is going to return that Unicode string. But remember, Unicode strings are stored in UTF-16. We need it to UTF-8, so we're going to UTF-8 string, but even that's not quite right. We need kind of like a container for it. Oops. And even though we have to give it a container to write into, it will also return that, so we can just return it directly. Fingers crossed, this should work. Our test should pass. It does. That is good. Now let's break some stuff. So, of course, we didn't have anything. In fact, we're just going to call this substr. No, if I'm going to do that, substring. There we go. Now, if I say A, this should pass. It does. They say, Corey, this is simple. Let's try a harder one. I'm going to do... This is gonna... I've got a link here that we can use. Where are you, window? You are right here. So there's a nice little website, unicodelookup.com, and I can say, show me the $, and there it is, $. Let's do a $. but let's do something else. And let's do something that has more than one. So more than one code point. And that is something that's going to be like British pound is what I meant right there, that. And I could, well, I might be able to. I could paste it in. But I would rather do it this way. I would rather use the hex encoding, and it requires 4 digits. So we can see here that that's what I wanted. Pound sign. A3. But we have to use 4 digits, so it's 00A3. And if I now do 1, it should be just that. And if I do 01, oh wait, 02, I should get both of them. Let's see if that works. Oh, I said A, and it should be a $sign. $sign, $sign. Still working. That's always a good thing. Let's throw a third one in. And one that I happen to know is large. So the British pound is actually 2 characters, 2 bytes in UTF-8. Let's do the Japanese yen symbol. There we go. We can copy that there. And why does it... Is it E586? There's another website I can use that I had. There we go. There we go. 5186, is that what the other one was saying? Nope, it was saying something different. Okay. But it will give me the actual code. So we will say... There we go. And now nope, didn't mean to do that. I meant to 2 1 5186. Okay. 5186. And just trying to think if there's, I mean, yes, I want to, there. So 1, 2 is going to be slash U00A3 followed by that. And then if I do one more and say 0, 3, it should be the $sign. All of those should pass. Okay. And by the way, in case you're curious, if I do a cout of S substir well, let's do the 0, 1. And then just do it for 1, 1, and 2, 1. Oops. What did I break? Oh, it's a Unicode string. No, substir should return a string. So I'm doing something wrong. Go up far enough. Oh. Yeah. I need to provide a method. Let's just do that really quickly. Let's do a cast the actually trying to think of what's the best way of doing this. You know what? For the moment, that's in the weeds. So let's go back to this, and the easiest way is substir of 0, 3. There, that'll give us the entire string. There. Okay. So that you can see, this is the 0, 3. This is 0, 1, 1, 1, 2, 1. And so it is, in fact, pulling these. That's what we want. Now, the problem with that is these are, even though they're multi-byte, well, the $sign is a single byte. The pound symbol is a 2 byte, and the yen is a 3 byte. How do I know that? I just happen to know it. But there we go. At least this UTF-8 text, you see that it is 3 bytes, whereas if we do the $sign, you'll see that it is a single byte. And if we do the grab the pound, pull this back over, you'll see it is, yeah, 2 bytes. So, yeah. I just minimized that and I didn't mean to. What I want, and I didn't think about this ahead of time to look it up, but we're about to find it. So, Unicode Scottish flag. I think it's the Scottish flag. Yeah. The Scotland emoji is a tag sequence combining the black flag, the tag small letter G, the tag small letter B, so Great Britain, SCT, and then the cancel. There. Let's copy it. Why? Because paste it in. And that should all be one grapheme. So let's try this. I'm going to flank it with $signs, again, just so I can test. But that's what I want. And substring 1, substring 2, okay, so this should be now 0, 1, and 2 with 1. That's going to fail. The first one will pass, the second one will fail. That's my prediction. Especially when I didn't think to So, in case you're wondering, where's Notepad? Plus plus. Oh well, I'm in the middle of something else, but replace not the U's though. Excuse me. D with an uppercase. D. B with an uppercase B. Oops. How about C with an uppercase C? They need to be all uppercase. Are there any others? F. F with an uppercase. F. Are there any A's? And now I'm going to have to $, paste $, and for this one probably needs to be again wait, what? These should be oh, it's probably just in how I'm doing it. I'm pulling it as UTF-16. Should have been using this one. And I don't want to remove that. I need it to... I need these to be uppercase. Is there a fast way of doing that? I need to figure this out for the future, but let's just do this again. Replace an A with a capital A B with a capital B, a C with a capital C, a D with a capital D, an E with a capital E, and an F with a capital F. There's probably a faster way, but I don't know what it is off the top of my head. So, $, paste, $. There we go. Okay. Now, we see 35. Oops. Need to get on the right screen. 35 right here. Failed. This one passed, 34 passed, but 35 failed. And the reason is if we look at what it gave us, it only pulled out XEF, XBF, XBD. It only pulled out 3 bytes. And that's we need it to pull out however many it is here, however many code points that is. If we look at it, if we look back at the 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is that right? Is it 14? Things, yeah. No, some of these may be multi-byte themselves. $32, maybe 1, 2, 3, 4, 5, 6, 7 code points, maybe, and of course that's spread out over 32. But okay, yeah. So how do we do this? Well, welcome to why ICU can be difficult. Now we're going to start doing some work. So the first thing that we need is in our Unicode. So this is our file, our Unicode string.cpp. We are going to create a function that is just for inside of here. It's not meant for the outside world. So in order to do that in C++, you give it a static, and this is going to return a standard vector of, let's try size t. The goal of this is we want the vector to include all of the grapheme offsets. All right, so what does that look like? Well, let's just call that get grapheme offsets, and we're going to pass in let's pass in the string. All right, and the goal is we're going to then say a vector of size t, and we'll just say offsets, sure. So worst case string is standard ASCII. Why? Because that requires the most amount of entries. So offsets dot, we can reserve or ask it to reserve, and oh yeah, there's just a length, but it needs to be length plus 1. Why? Because we want to have 1 past the last character, because of the way we're going to use this offsets. If there are 3 graphemes, then entry 0 is going to be 0. Entry 1 is going to be wherever the offset count for that second grapheme, and offset 2 is going to be the offset for the third one, but we need to know how long that is as well, so we will then take a 4th entry. So if it's 3 characters, there needs to be 4 in this offsets list. Yes. All right. Create a ICU character break iterator. Identify the graphemes. Okay, this is where it gets harder. First of all, in order to create an iterator, we need an error code. So, is that error code, I believe? And I think error is what it's often called. Just there is no error, and now it's going to return a reference. So we might as well use some modernish C++. I don't need to say. I do need to pound include memory though. There we go. And this is going to be a unique pointer of an ICU break iterator. Yeah, we'll just call it iter. And in fact, this is kind of similar to what I did in my posts on Stack Overflow that didn't get answered yet. And there's a static method called create character instance, and we have to give it a locale. And this is something that in the future we may be able to let this be configurable, but for right now we'll just use the default. And why would this work? Well, because why does it need that? There's other types of iterators. There's word iterators. There's sentence iterators. But they can change depending on what language. They change their behavior. So I think this should be safe with just using get default. We'll find out. And then we give it error, and it's going to, if there's an error making it, it will be returned an error. So all that we're going to do is we're just going to, I think we can assert. How did I do this? I'm going to have to look this up. Stack Overflow ICU grapheme. Not going to be able to find it quickly enough. One moment. There we go. Okay. So assert u underscore success. That's a macro, and we just give it error. So this should be optimized away when we're in release mode. And now I'm going to use. Do I want to do it that way? You know what? I'll just go ahead and show. This is kind of what I had written before on Stack Overflow, and as you can see, and I was like, hey, this isn't working. Here was my problem. I was expecting it to be 0134778. In other words, I was expecting it to be in telling me the number of bytes to skip in UTF-8 encoding, because that's what I was giving it, a UTF-8 encoding. No. It converts it to UTF-16, and then it will... Oh, and by the way, in my example, I was giving it these code points, which I now know I should not be using that method, but it just happened to work. But I was giving it something that when it converts it into... oh, I'm sorry. This is... well, you can see in the output I was giving it a $, pound, $, yen, $, just to intentionally do it. Well, anyway, the yen, for example, even though it's 3 bytes, it's still only 1 code point. And so it was doing exactly what I'd asked for it to. I had misunderstood what it was. And by the way, I linked to 2 answers that imply that what I was thinking was correct, but oh well, that's one of the reasons I'm recording this, so that you can see it. So I say don't copy, but we're going to copy here. And all that we're doing is auto current is equal to iter current. So iter current, what it does is it just says, give me the offset that you're currently on. And since we just created it, it is going to be 0. And then while iter arrow next doesn't equal this ICU break iterator done. Now, what is that saying? Well, iter next increments, it goes forward, looks for the next grapheme, and then it does it in place, and what it returns is either the current position, or if it's gotten to the end, it will return this special value, this break iterator done. So it's just going to say keep going until you reach the end. Now, iter next is it's the only one that does it. Iter current never returns that break iterator done. So we'll use that fact in just a moment. But do we need to? Well, oh well. And I was printing it out. We don't need to do that. What we need to do is we need to say offsets.push back current. Yes. And then current is equal to iter arrow current. Why? Because we've already incremented iterator here. And so now we're just setting it to the new value. When it exits, we should just be able to then say offsets.push back current. Return offsets. And now let's just say I'm just saving it so that we can make sure it compiles. Okay, it says we declared this function, but we haven't used it. Okay, that's fine. We're about to use it. So now our substring, we're going to say auto graphemes is, maybe it's offsets. Get grapheme offsets of our use string. And now we're going to write something that's going to break. Or that we're going to break in just a moment. But we're going to say offsets of subposition, and then offsets of, because I need the length, and what's the length? It's going to be offsets of position plus length, because our calling code thinks of it just as one thing. So if I'm asking for a length of 1, then that's going to be position plus 1, and that should be the next entry. What happens if I ask for 15 and there's only 3 there? Well, that's where I said it's going to kind of break, but we'll fix that in just a moment. Oh, interesting. That. So we've broken everything. Oh. Position plus length minus offset sub position. Yeah, because we need the length, not the ending location, but the length. And now did that run? Or did I overlook something? It is running, and it is failing. Failing spectacularly. Isn't that always the best way? Okay, so substring of 0, 1 returned nothing. So let's track this down. There's a couple ways we can do it. Try reasoning about it. Who wants to do that? So the first one, so 0 to 1. What I'm going to do say cout, and of course I don't have IOStream. Remind me to remove that. And now we'll just say for auto I in offsets cout I and line. All right, this is just so I can see what's in this offsets thing. Did I make a stupid mistake? Happens. You know. So the first one, 0, 0, 0, 0, 0, 0, 0, 0. I think we have a bug. Oh, I know what. I never told the iterator to use the Ugh, I can't speak. Did I close that window? I never set the text. See, I promise, even though I had it on the screen, I wasn't actually copying. So let's just do set the text to iterate through, and that's just going to be iter arrow set text and str. Hey, everything passed. And you know what? We can see this now. So let's go to the to our tests. The very first one, we say, I mean, that is an empty string, 0. The second one, there's an A, so 0, 1. That works. Now, so this one, I'm happy it didn't die on us, but we'll keep going. Okay, so for the third one, this one right here, 0, 1, 2, 3, and that's because each of these is only one long. But when we go down here enough, there we go, 0, 1, 15, 16. And that is 0 is the $sign here, 1 is the start of the flags, and then 15 code points later is the final $sign, and then 16, of course, is the end. Yes. All right. So let's make sure that we don't cause any other undue problems. First of all, we'll... Now, there's got to be a really nice C++ function for min and max. Probably in CMath. Standard min. Don't tell me I had to include algorithm. I guess I do. Fine, we'll do it. Or max. So, all right, we will IOStream. We'll replace that with algorithm. And so what are we going to do? We're going to say sanity check. If position can't be, because I was about to say if it's less than 0. Size t. An unsigned integral type. Yes, so it's unsigned. Okay, so we don't need to check if it's less than, but we do need to see that if position is greater than the number of graphemes. We can't do that until we get the graphemes. So here's where we will say our sanity check. If position is greater than or equal to, because y equal to, because offsets is one more than the length, offsets.size return that. Now, for this, we need it to be position.length. This needs to be the max of position plus length. I said max. I meant the min. A position plus length and offsets dot, no, not dot size. What would that be? Offsets minus position. Is that right? Or do I have an off by one error? If the size is 2, and I'm saying 1 and 1, that should be fine. What if I say 1 and, but 2? Wait. Sorry, it's been a long day, and it's past midnight for me, but that's okay. Since I figured this out, I mean, got this going, I wanted to make sure that this worked. Actually, this, you know what? The test will tell me, but I'm pretty sure I'm right. Or so I thought. That should be greater than. And that is telling me, yes, I have an off by 1. All right, and now how do we test this? Well, that's simple enough. We just do another. Okay, so this is going to be, oh my goodness, how did I get all of these off? This one is an empty string. And what happens if I say zero? It should be, if position is that, nope. First sanity check. If length less than 1 equal to 0, whatever, the point is there. Second sanity check. All right, so we want this to be both of these. That's good. And why am I doing this here? Well, I know why, but the point is to make sure that it works in an empty string or even on a string that has some characters. And let's also do that should fail because this should be empty. I just want to make sure. Good. All right. Now the Unicode. Okay, so testing an empty string. One character. Testing multiple. Unicode. No. Multiple graphemes, each made of a single Unicode. No. I mean, it's a, I want to say Unicode point, but that's not the right word. Code point. That's the word. And then this one is testing multiple graphemes, one of which is a multiple. Yeah, one of which code points. And this, there we go. I think I'm going to make a change here, and I'm you can change it to anything, a period. The point is that it's different from the $sign. And if we put a period there, and let's make this one 0, 3, not a $sign. So what are we testing? We've got we've grabbed each one out individually. We've got and I'm still wanting to test that and I meant for that to be a 15, don't know why. But if I do this one, I want this one to be 30. Sure, why not? But it should get everything. All these should pass. Oh, it did not. 0, 30. Why? I mean, I know why. It's a good thing I tested this, but it returned an empty string, whereas I expected it to return everything. So I've done something wrong. That's why we have tests. The first sanity check. If the length is less than 1. Now again, at size t, it can't be negative because size t is unsigned. But the spirit of this is that there's no length. Okay, compute the offsets. If the position is greater than or equal to the size, that means it's gone off the end, return. And then we perform the substring, and this is what's getting it. So the offsets sub okay. The minimum of position plus the length, or why did I have minus position? It should just be offsets dot size minus 1. Because it don't know what I was thinking there. There we go. All right, so that was capital J that returned that, or that joined those together. And now we've got it. We have the first step of working with ICU. That is, we are able to create a string in Unicode, first thing, and get substrings of it. Everything else follows from this. Being able to reverse a string. We could try it with other tests. There's Zalgo text if you're curious. It's just choose the first one, you know. Hello world, and it just adds diacritics above and below it. And here we can simplify it a lot, or you can add endlessly. I guess it's from a meme of about 10 years ago. This will handle that now. Yeah. The only thing I'm going to add here is the Scottish flag. There. Just wanted to add that in there. And now, what do we need to do? So get diff. There's not going to be much in there. Well, I mean, just the fact that we're... And now we've got 3 new programs. What I normally do, let's say make clean and just to make sure that it's working correctly. Source Unicode string, and then test Unicode string. There we go. Everything's passing. We're going to do that. Now we will update our documentation. Let that run really quickly. And in the meantime, what episode are we on? Episode 45. There we go. There. Nothing else changed? Yeah. A few new files, of course. Episode 45. All right, last thing. How are we doing? Oh, I guess we could have seen how many lines, but I didn't. I guess I didn't look when we committed it. But there we are. We're almost at 5,500 lines. And that's just straight code. That's not counting the comments. So that's good. Again, we don't measure quality of code by the number of lines, but it does at least give us an indication of how much work we've put in. And it is good to be back working on this. And it took a few days for me to figure out what the problem was with my own understanding of how ICU was working and my assumptions of how it was working. But all that to say is we're in a good place now. And with that, I will say thank you again for joining us, and we are now going to start working with ICU a lot. But the biggest thing that we needed to do was get it to group graphemes together for us, and that's what we were able to get done today. So the next one, we're going to look at how we can replace the standard library string or standard namespace string with our string, and what needs to be done. We're going to have to do an operator equal for it, an operator plus, and I don't know what else. Maybe the comparison operator, less than, greater than. Again, all are going to have to pass through to ICU's implementation of it, but I think that's what we're going to be working on. And after we get that, then, and here's the best part, we can start doing things like slicing, which is one of the really nice features that Python has. How you can slice strings and do skips and have negative offsets to count from the end. And that's one of the things that makes Python so great for string manipulation. And that's what we're going to add into our programming language. Just it's Unicode aware, and you'll get it out of the box. Yes, that's what we're going for. Again, thank you. Have a great day, and I'll see you later.